No change. You wait.
I'll stay. If there's anything, just. I'll go.
Okay. All right. Thank you very much, Sarah. Paula, how long are you going to talk for? All right.
Sorry, can you say the question again?
How long are you going to talk?
Oh my God.
6 minutes.
Quickly. Or 7?
Yeah, we just put 10 for backup of how long we start, but I think 6 minutes will be enough.
I was living in hope, Dan, that you had 10, but you don't.
Yeah, so Paula, just to let you know, it's time we should try to actually communicate that to everybody that we've changed the time.
Dan thought he was talking to 10, which is why he has such interesting.
I'm just.
It's a rally. I'll speak less and you can speak your 10 minutes. That's fine.
Depends on how much they're called.
Andrew.
Okay. Yes.
I think I hold that.
Okay.
But it is
Oh, you
really
do?
more
Oh,
than
there.
the other.
I have. Yeah, there were there's
Yeah.
Few more pen days to make sure.
They should.
Yeah, yeah.
That's
Here. There it is. Okay, then. Yeah. I think that, yeah, my husband is stuff. Sorry.
it's not flat. What is it? We might start kicking this off with some housekeeping, and welcome to this session. You can read it, Coordinating Mechanisms for Making Code Visible. The person who organised and devised this session is actually online. Paula, this is your cue. Would you like to say hello to everyone, please?
Hi, everyone.
Well done. It's a birds of a feather session, so it is not aligned to any interest groups or working groups or any particular organisation or country involved in the RDA. It's generating ideas and that sort of thing. And please note, we'd really like you to write your name and details down, if you can remember your orchid number, that would be great, in the form that's going around in the room. And for the people coming in online, welcome. And we have give you a link very shortly. Paula will populate the chat, I'm sure, and we'll show it on the screen as well. It's on the form going round, the link to the notes page. On the notes page for the meeting, we also would very much welcome any comments and thoughts that you may have, as well as any contemporaneous record of what people are saying and what might come into their heads. Please note also that the RDA Code of Conduct, so that we are respectful of each other, and of course, being a hybrid meeting, we're going to try to talk reasonably clearly and slowly so that people remotely can understand and hear. I think that's about it, Paula. Is there anything, or Catherine, have I missed anything in particular? So without further ado, maybe we'll start moving and we'll hope that the slides actually move forward. No, they don't. There we go. So we have a fairly packed, not too badly packed session, a fairly well-designed session, I would say. I pack sessions, but Paula designs them. First, Paula will give us an introduction and to the whole scope of the session, and then followed by some lightning talks. I'm one of the people talking, but we also have Leslie McIntosh, Daniel Katz, and Alice Allen. And then we'll have some activity where Paula will come back and then we'll have some takeaways. So the last few people are coming into the room, so just please, for those people, I'll repeat, please do take a seat and make sure you enter in your name and contact details either on the form that will be floating. There are more than one form page floating around the room, and those people online, please do the same. So don't forget. Okay, so first, that was me. I come from the University of Queensland, and each speaker, by the way, will introduce themselves. And maybe I should do that. I'm here partly because I come from the same place as Paula. So we were able to have a little chat beforehand. But I'm also involved with the terrestrial ecosystem research infrastructure and have long been involved with synthesis centres and such things. So, you know, and the RDA. So that's where I come from. But here are the collaborative notes, and the link to the slides will be static. So I'd keep watching the screen here, or if you're online, the screen in the RDA conference page. This link to the slides are static, whereas the collaborative notes are very active. Okay, so this bird of feather aims to discuss research software visibility, obviously, from the title. And we hope that we will highlight to the audience some new information, in particular about existing mechanisms that might help make code visible. And we go at this in quite contrastingly different ways. And by means of the last phase of the session, we'd like to collect community input about other mechanisms and future coordinated actions. So I hope you can enjoy that section, as well as everything. So first, I'd like to turn over to Paula, and I will probably stand here, Paula, and advance the slides if necessary. So thank you.
Thanks, Alison. Can you hear me?
Yes, very well.
Okay, good. Thank you. So for those that just arrived, I'm putting the links in the chat. My name is Paula Andrea Martinez. I work for the Australian Research Data Commons and also for the Research Software Alliance. At ARDC, I'm the software project coordinator, and at RISA, I am the community manager. Thanks everyone for being here and so many options to choose from. We are here to talk about code visibility and why is it important. Please, next slide. Okay, so I wanted to put the frame of this both as I'm going to refer to research software and its short form referring to code. And like one of the earliest speakers in the morning said, Rose Wilkinson, data is a global asset. And nowadays, research software, it's also a global asset. It's everywhere and it's essential for the advancement of research. It's also leading to innovation because it's a representation of different ideas. Software, it's built to improve our manual processes, and in that way we can accelerate our knowledge and also the accuracy of our results. For the purpose of sharing software in a meaningful way and referring to the 5 principles and the letter R for reusability, source code is the most useful form of software for reuse because it can be understood by people and also by machines. And another aspect that I want to highlight when we have this discussion is that software continues to evolve, and it's a necessary quality for it to be maintained and updated. And we live in this rapidly changing environment, and thus adopting software will always be necessary. Next slide, please. From the previous plenaries that I've attended, a lot of people start by defining what are we talking about. So I wanted to give you a little definition to frame this both. What do we mean about software visibility? By visibility, we mean the degree of ease through which a user or a machine can identify, can find, and can also take next steps with software coming from different disparate sources. So when I mention machines, I give you a few examples. It could be an API, it could be AI when we talk about AI-ready data, AI-ready software that can be reused by machines immediately, and also by search engines that will facilitate the findability of this software. Next slide, please. Thank you. And then why software visibility is important. So I've listed a few options, but I could think of many more, and I'm sure each of you with your own hats will think of many more important features of why visibility is important. That's why you are in the room. But I'll cite a few ones. So we want to avoid reinventing the wheel. There's few things that we can reuse, and then we can save time if we are able to find the software and reuse it instead of doing everything starting from zero again. The more software visibility that we have, the more software interoperability that we have. And that is extremely powerful when you think about different aspects and different needs from different points of view. When we talk about resource allocation, if you are with your infrastructure, you know that this is expensive. So the more reliable and accurate the software is, that will improve resource allocation. So we won't have to use things that are too expensive. We will just measure what we need and use it at the right time. It also identifies risks early. So one of the reasons why a lot of researchers don't want to share their data or their software is because they think, oh, people are going to find errors and then that's going to make me look bad. But actually, when they make the software visible very early, they can also identify the risks early, and then that will save them time and corrective action will be reduced. In the same way, identifying and solving problems early, it's much cheaper earlier than down the road. And we can do this by making software visible as well. And in science, transparency, one of the important things is that if we share the software that is producing results out of an analysis, it will also increase the confidence in those results. Because if we know what the steps are that we took to get to a result, that will help us decide whether this is the right software that we need or this is the right process that we need. And the last point that I wanted to take that's also going to be discussed during this both is that team members can take ownership of the project. And if we go to the next slide, I'll give you a few examples of who are the team members that I'm referring to. So there is a concept of RSEs, and RSEs is research software engineers. These are people at the intersection between programming and special knowledge of a research field or a domain-specific field. And research software engineers are not only interested in developing software for the sake of developing a product, they are interested in developing software that will aid to get results and to make software as a research output. And this has a question: is software a research output? And I believe that people in the room agree with this, and that's why we are here writing code is research. It takes a lot of time and effort in its reviews, and it also needs to be visible, such as paper publications. So we are going to discuss how we can publish software, how we can normalize this, how we can implement new metrics, how we can engage people who are working in this, and then take all the stakeholders into account. That's all for me for the introduction. Now we will move to lightning talks by different speakers, in which they will give you different mechanisms to make code visible. The QR code there, it's for the collaborative notes. If you just arrive, you can scan that code and add your details to the attendee sheet. Thank you.
Now, unfortunately, I think the remote people can see the speaker's face. I am terrified of mucking up the presentation, and so I'm not actually showing the face up the top there, but for which I apologize. But hopefully the remote people have the advantage. Oh, there, she was in time. Now, we've now got Leslie McIntosh, who'll be talking about setting the scene, data and software availability across fields today and challenges. And Leslie, you've got around 7 minutes, which isn't very long. So I hope that's okay. And I'll get you to, if you wouldn't mind, introduce yourself to the audience. So I won't talk on there yet. You tell me when to advance the slides.
All right. Thank you so much, Alison. Thank you, Paula, for having this. And thank you for having it in a hybrid so that I could change my plans and be available online. And thanks for everyone who's there. So I have the pleasure of working with the group and being asked to set the stage for data and software availability across fields today and challenges. So this is really an overview of where we are with the data that I can see, and this is from publication. So if you can go to the next slide. I just want to take a step back, and the way that I look at this is through trust markers. Now, trust markers are basically Cynthia Hudson-Vitale, who is a librarian. She works with ARL, and she introduced me to RDA many years ago, and I've been very active in RDA. She and I and our team members have gone through the literature, looked at checklists, looked at literature, other guidelines from research integrity, and mapped what are the common themes that from a research publication perspective that would indicate trust. And if you can see in there, there's reproducibility, and then there's the data availability statement, which we've talked about a lot over the past few years. And there's also code availability and code availability statements, software citation, analysis software. And the reason that I point these out is because one of the things I think the community is going to need to think about is, as we're trying to understand the visibility of code, what do we expect it to look like? How do we expect to find it within publication? Now, I know there's other ways to find it as well. I'm just talking about one. Go ahead to the next slide. Yep, one more. That just is for everyone. I think everyone can have the slide so that you can see that it goes into more details. So if you look at data availability statements, you can look at data location. There are buckets of data location, supporting files within the paper. A lot of these have been discussed in the literature. The paper that has stuck out for us is Lisa Federer's, who comes from the US NIH. But you can dig into data repositories and see if people have had a data availability statement, if they said where they shared their data. And I say that because they also sometimes put their code there as well. We are also looking for code availability statements, which is different than looking for any code in a paper. And the reason that is important is because it gives us an indication of where the community is moving. People started sharing some data before they had data availability statements. Maybe not a lot, but some. And we're seeing that with code availability as well. Do you want to continue? So if you take the reproducibility trend, so all of those items in that were in reproducibility or at the time, we applied the algorithms to 12.4 million papers, research papers. And what we found is across fields, there has been a slight uptick in the items for reproducibility. But in 2020, we saw a much greater uptick, even though there's still a lot of room to be improved. But this is the COVID effect, the pandemic effect that we could see across fields. So next slide. So this just kind of takes more than just code, but is looking at where is it in context of other trust markers. So we've seen a great increase in everything, which has been nice. Code availability, though, as you see at the bottom, is rather new. It's calling it out as its own entity, as a value for itself within a paper. It's pretty new, starting around 2019, especially compared to other things like having a funding statement or competing interest in ethics approval. Next slide. One of the things that we can dig into is where are people putting their data and sometimes code right now. And I'm giving you some of the data perspective with code because we have some of that information. And one of the things that you can see is there are many repositories that are being used, a lot of the genomic ones, and that will vary whether it's just the data and or code. But the thing that is a little bit concerning is that GitHub has seen a great increase. Now, if you go to the next slide, I think a lot of people will know that GitHub can be for code. It can be, and that's more of where it comes from. It could also be for data. It could also be for anything else because it's not technically a repository. So it's actually very difficult to understand what is in GitHub versus what is in other repositories, especially trusted repositories. And I contrast GitHub to Figshare, Zenodo, OSF because those are generalist repositories. It could be that people are putting code in both of those, but it's hard to tell. The other thing that I wanted to just give a picture of on the repository, which ties into where code is going, is that there are different conversations depending on which field that you're looking at, because they tend to use different repositories to put their code and to put their data. But this is more on, I think more on code on this one. So it's a good place to just get an idea. None of these are great, but some, obviously, information and computer sciences depends more on GitHub or utilizes more of GitHub, and psychology, OSF, because that's where OSF came out of, that's the field. So just trying to give you an overall landscape picture of where things are. We can go to the next slide. I think I'm done, and I think that's 7 minutes.
That is
All right.
wonderful. Wow.
Thank you.
So that was great. But now we will move on to Dan, who is in the room. So I can probably just close this up if I manage to do it better for a while, and I will go back so you're not. There you go, and you're happy to move it on.
Great, thank you.
Great.
Okay, yeah, so thanks. It's a pleasure to be able to talk about code visibility. I'm going to talk specifically about code and papers. So this will build a little bit on what Leslie was saying. And I guess just before I start, I wanted to mention that the thing that didn't show up in Leslie's presentation, but I think is probably the interesting thing to look at is software heritage. And I think there's somebody from software heritage here. Yes, okay, a couple of people, so yep. But I think this will be part of the conversation as we go forward, even though it hasn't been in the, I'd say in the information science, library science view up to this point so much, but it should be going forward. Okay, so if we're talking about software and papers, as we heard, the software can show up kind of in line in the paper body or in the acknowledgements, but we've been doing a lot of things to try to make formal citations better, to make software show up like other things. Ideally citing the software itself, as opposed to a paper about the software, but maybe citing a paper about the software. And so I'm going to talk about some work that was done in Force 11 in 2 different software citation working groups. Neil Chuhong is here somewhere. Yep. Okay. Who is the co-lead of one of these 2 groups as well. So more to talk to if you have questions afterwards. What we did in these 2 different groups from 2015, basically up through kind of last year, maybe this year, depending on how generous you want to be to us, is that we've been working towards making software citations a way for software developers and maintainers to get credit for their work, because we think that leads then to better and more sustainable software in the end. And having that software be sustained also then leads to support for reproducibility. So just to walk through this, and we started with a working group that was just looking at software citation, specifically building principles. And what we did was to document the differences between software and data, because probably everybody here in this room knows that software isn't data, even though you can store it as data, but it has lots of different properties. And those properties then lead to different characteristics and different reasons of how you apply citations to it. So again, we documented the differences in a couple of papers, and we created a set of software citation principles in 2016, and that was published in PeerJ Computer Science. And those software citation principles basically in brief include importance, that the citation itself actually is important, credit and attribution as the reason for the citation, a unique identification as a property that we want the citation to have, persistence, another property that we want the citation to have. If the software is gone, we want the metadata to still be there and to be able to, for somebody to know what it was. Accessibility, that ideally the citation lets you access the software that's being cited. And specificity, which is really related to the version of the software, because, and as people in here probably know, there's lots of versions of software. Typically, it changes fairly often, and you'd like to be able to tie the work in a paper to the specific version of the software that was used in that paper. So after that was done, we had this idea, okay, we have these principles, let's start a working group then to do implementation. And all that we're going to need to do is to write out a little bit of detail that's going to be needed to implement the principles, and we can coordinate all the different people that'll be happy to join in. And we'll work with some communities that actually want to do this, and we'll be done in a year or 2. And that turned out not at all to be the case. We ended up writing an archive preprint on the implementation challenges, and we discovered the challenges were much, much bigger than just getting people to say that this is a good idea and start to do it. The technical challenges include the fact that software are extremely complex, from source code to containers to services to other things, and that identifiers are also very complex, where there's GitHub IDs, software heritage IDs, PIDs, ASCL IDs that Alice will talk about after this, and a bunch of other IDs that are discipline specific. The social challenges are that there's groups that need to actually work on this in context in different areas. Disciplinary communities, publishers, repositories and registries, indexers, funders, institutions, and so all of them need to come together and actually start working together in order for this to happen. So in response to those challenges, we set up a few different task forces and had those task forces work. So one of them was a guidance task force, and Neil led this. And this came up with 2 checklists as documents, one being a checklist for authors, being authors of papers, saying, if you want to cite software, how should you do this? And the other being a checklist for software developers. How should you make your software citable? So those were 2 initial activities. We had a code meta task force, and code meta is a project that was aiming to understand metadata for software in general, not just for citation, but for other purposes also. It built a crosswalk of metadata standards for software, and then it developed yet another standard to describe software based on those crosswalks. So if you know the 14 standards joke that leads to the 15 standards, then this is a good example of that. So the code meta task force then updated the code meta standard. It described everything in code meta using schema.org properties, and it's now moving code meta into a community group that will be based on schema.org. So it doesn't have to do the same maintenance. It just help schema.org move forward and hopefully get better for software. There's also a citation file format, a CFF standard, that is much easier to use than code meta, but more specific to citation and much less general. So they have pros and cons. And the CFF standard has now been integrated into GitHub and Zenodo and Zotero and some other things. And so it's relatively easy to use, and it gives a way to for a developer to create a small file and to have GitHub then or Zenodo or Zotero understand that file and be able to create a reference that somebody can use in the paper. We had a software registries task force, and I think Alice is going to talk about that briefly or not briefly. No, okay. So the task force basically came up with a paper that's on 9 best practices for research software registries and repositories. And it's intended to say, if you are a research software registry or repository, what should you do about the software? What are the practices for how you take it in, for what if the software goes away, for things like that. And that community is continuing in an organization now called Psycodes. And if you're interested in joining, it's psycodes.net if you're running a registry or a repository and want to think about how you could be dealing with software. We have a journals task force, which has been working with publishers to provide generic guidelines that they can then customize with community accepted language and community accepted examples for their own publications. And we're working with Chorus to track the different publishers that actually have supported that. And we're also working on publication processing. So once you put information into a paper, you give that paper to a publisher, there's actually a kind of a long process that happens before that shows up in Crossref or something like that. So we're trying to improve that process. We talked about an institutions task force, thinking about places where people work and policies and practices in those institutions. We didn't get buy-in enough from people in our group to actually start that. So that's kind of on hold. And if anybody's interested, you could talk to me and we could see if we could actually get that going. And then we just had a workshop last summer that was trying to look at, here's the progress we've done, where are we now, and what else do we need to do? And there's a report on that that's just been published as well. So lots of stuff has happened over these years. We're now a little bit kind of in a hiatus for some reason, and we could, I think, potentially restart if there were interests in restarting things. But I think we've done a bunch of things, and we've kind of gotten to a point where we need other people to take things up now. So where we are, we have software citation principles, we have policies from publishers with examples, we have tools that support processing and indexing. We have some uptake, and that's increasing among developers and authors and editors and reviewers. And what we need is more uptake and policies from stakeholders, as well as discussion of what we should be trying to work on. And so maybe we can talk about that in the very end. The last slide I'm going to give is that there also are software papers. And software has been recognized as an element worthy of discussion and publication for a long time. I have some examples that I found. If you know of earlier examples, please let me know. But the first software basically conference seemed to be in 1954 that had a proceedings talking about software. There are journals that started talking about software in 1969 and 1975. There are papers that are early software papers that seem to have started in 1973, as far as I can find. Neil has a list of journals where you can publish papers, and there's also newer journals that focus on not just the paper, but also the software and reviewing the software in a peer review process. And Journal of Open Source Software, Journal of Research Software are 2 examples of that. And so I will stop there. Thanks.
I'm very pleased there's a static copy of the slides, remember, up on this website. We have a link on the front page, so we can go back and read some of that. But first, now we have Alice. Might move this over here. Because we're going to.
Because you know I'll knock it off.
No, we're going to do a tag team, and I don't want you to worry about that, about a glass. Okay.
Okay.
Alice, please introduce yourself, and I will
Okay.
just make sure that
There's
progress
the
goes well.
I'm Alice Allen. I'm the editor of the Astrophysics Source Code Library, which is a registry for software. And so I'm going to talk about enabling discoverability and visibility of software through registries. For this presentation, I'm going to use the word registries to cover 2 basic types of code resources: repositories, which require that you deposit the code in them, and registries, which hold information about code, including usually where to find the software. Because most repositories also include at least some metadata about software. Oh, we need to advance, sorry. So yes, this is where.
We'll get there.
Okay, yes, there you go. Okay, because most repositories also include at least some metadata about the codes, the term registries fits both very well. So thank you. So there are many places to put software and information about software. They have these different repositories have different goals and different structures, but we might group them loosely into these different categories. So there are national efforts such as the Australia Research Data Commons, which you've heard about, HAL, which is in France, and the eSciences Research Software Directory, which is out of the Netherlands. There are organizational efforts also that can be university-based, such as Caltech Data and Colomer's eCommons, which we heard about today, but also government agencies such as the US Department of Energy, which runs DOE code. And that is for any scientists working at DOE to put their, not just their software, but other research artifacts in also. And also, if you're funded by DOE, the expectation is that your research artifacts, including software, will go into DOE code. So that's important. There are general or open repositories and registries such as Software Heritage, which is very interested in not just research software, but all software. Business software, everything. So that's one place. And Zenodo, which you've already heard about as well. Zenodo welcomes all research artifacts, but is also a place where people do push their code from GitHub. There is a GitHub gem where you can push your GitHub repo to Zenodo. And then there are discipline-specific registries, such as the Computational Infrastructure for Geodynamics, BioTools, which serves bioinformatics and the life sciences, and Astrophysics Source Code Library, which is the resource I run, or ASCL. So you'll be hearing a lot about that because I'm speaking from that perspective. So we can say that though there are all different kinds of registries and repositories, that they're all places to look for software. I'll share some of the things that the ASCL does to make software more visible and more discoverable, how our metadata is used within our discipline. But these are the ASCL's examples. Please note that other registries do many of these same things as well. We collect information about codes, yes, and provide a site where people can search to find software. It's ascl.net. If you want to go there, you know, do. But other good things come out of our collections. Collecting this information, let me go to a new slide. No. Collecting this information creates new opportunities. Just as journal papers get published, they are then indexed by, for example, Web of Science. The ASCL's collection of information can also be and is ingested by indexing services. So our metadata appears in Web of Science and in Google, on Google Scholar, and most importantly for the Astro community, in Astro's main indexer, which is the Astrophysics Data System. This is commonly called ADS, and I'll be referring to it that way. Having the information in more places researchers use make this information easier to find. So you're more likely to stumble across this in one of these codes because it's in multiple places that you as a researcher use. So in addition, we, as do other registries, assign a unique identifier to our entries, and this makes our software entries citable. 15 years ago, when I started, so the ASCL was started in 1999. I started working on it in 2010. And back then, 15 years ago or so, some journals actually actively discouraged or barred formal citation of codes used in research. Like, we think that's crazy today, right? Isn't that nuts? So we worked with journals to encourage them to allow citations to research codes. And now many of them, including all the major astronomy journals, require that software that enable research results be cited in the bibliography. And as you can see from the graphs, this is ASCL data. You can see that citations have grown over the years. We've already outstripped, so in the 2-year period that we're currently in, we've already passed the 2-year period previous, and it's only March, so, you know. So citing codes also provides exposure and visibility for the software. You cite the software, other researchers are going to read and see the citations. Indexers have a lot of experience in tracking citations to journal articles. In order to track software citations, indexers have to know what to look for in bibliographies, and information in bibliographies has to be formatted in a way that indexers can recognize and capture. ADS does an excellent job of tracking citations to the ASCL entries. Here you see an ASCL entry for software called Delphote. golf boat. I'll never get this right. And you can see that there are 101 citations. That's not the most cited software entry in ASCL, but it's one that I like to use as an example. So you can see that it's been cited here, but that's not all. Yeah, thank you. ASCL, so ADS also uses ASCL metadata to link golf boat, for example, to articles that it is described in and is used in. So, and the converse of that is also true. So ADS links this stellar photometry paper, this is a research paper, to the Delphote software in related materials. So there we find, and you can also, let's see, in the previous one,
Previous one?
yeah, let's go previous. Oh, down to, all right, that's all right. All right, so maybe it's the next one. Anyway, so, or maybe I took it out.
Ah.
Oh, no,
Up to
here.
7.
No, I'm sorry, it's right here. Data products.
Yes.
So ADS does a really good job of tracking journals, journal papers. It also tracks conference, it ingests and does conference proceedings, all kinds of scholarly stuff that is related to astronomy research that is of interest to academia. So it also does data products. And as you can see here, it links this paper to the ASCL entry, to the code that this paper uses. So many other registries do these or other similar things and are now good. You're so good at this. And are now working together. Dan has already mentioned SciCodes. This is a consortium of scientific software registries, all different kinds. So most of the ones that were on the list that I showed you, most of those are members of SciCodes. Among SciCodes' goals are for member registries to render their software metadata in the codemeta.json schema by not taking away from the way we currently do it, but doing it in addition to how we do it. By formatting our metadata in a standard way, we can then enable searching across many disciplines, which make software much more visible and findable, discoverable. And so we would do that because we want to increase the visibility and discoverability of these important computational methods. So, were you claiming?
Yeah, you're
Okay. So if you have questions or want some stickers about another effort to expose astronomy software, we have something called the virtual. It's called VAST, Virtual Astronomy Software Talks, and it's an online seminar once a month where we talk about 2 software products and then have a discussion. So, I have stickers for that. And I'm sorry, I don't have any for SciCodes yet, but someday. So that's all.
Yeah, well, that was thank you very much indeed. It's getting richer and richer, and I should have been here. What did it do where I'm going to talk about some work that I've been doing with a project funded internationally by the international organization, the Belmont Forum, which is about science-enabled infrastructure work. And we've been working with 5 countries and trying to use artificial intelligence and deep learning to interrogate satellite images to detect the socioeconomic effects of the creation of protected areas on the local communities. Okay, so you can think big data satellite, big data sensors, over time, over space, different places, different types of sensors, and we've got a bit of a mess. Sorry, we've got a bit of an interesting, juxtaposition of all these bits. And as part of this project, we've been exploring how to do some of the stuff. And I feel as though I should have come here, but always one feels like this. You think, oh, if I'd known this before. Okay, so anyway, that's how I feel today. But I'm presenting with a group of people from Sao Paulo in Brazil, from the Escola Politecnica of the University of Sao Paulo. So their job is the DL and the machine learning, and I kind of interpret. But as we know, and I should time myself, do it to 6. We start off as general scientists, and this is the kind of the reality check. I wish I'd known beforehand what you all know much more about. Although my DL people, again, probably not as much as you, they know how to do it. But the gold standard that we do know about is to achieve full replicability and reproducibility if possible, to ensure open and accessible research. So we're not telling you anything, but that is the mantra that the Belmont Forum in particular, which wants open science and open data, is following. And Kathy's doing a photograph. Okay, so we started off with this. We did a project initially on the use of Google Street View to do this detection of images and work out the poverty or wealth indicators. And then we moved on to really looking at reproducibility. And we did learn quite a bit about how little reproducibility is actually practiced. Here we're taking something from a couple of papers that you'll see down below, where in fact 70% of researchers were reported as being unsuccessful in reproducing third-party experiments. Really sad bit, but I don't know, it's what the dickens did I do there? With if I haven't recorded my script properly or whatever, is that they were 50% of them were unable. Certainly the time factor will be part of that, to reproduce their own research materials. I can certainly relate. Yeah. Of course, and we're talking ancient history, 2018. Ancient history, so much has changed, maybe. 86% of people are reluctant to share code data or both. So this was a bit of a salutary lesson as we went to template papers that someone had been inspired by. Oh, we can do that. You DL people, just find the code and we'll rerun it. Okay, yeah, really good. Sorry about the top part of the screen. Pim and Tal in 2019, we're advancing a year, looked at Jupyter notebooks as one particular type of code storage and code recording. Only 20% of people were able to rerun a Python notebook without errors. And we're looking at 800,000 Python notebooks. So that was a pretty good experiment that Pim and Tal et al. Did. Only 4% of them managed to produce the same results. 50%, hey, got different results. How interesting. For more than half of the notebook cells, which we rather quite liked. So we felt better once we saw this, that it wasn't just us. And here we have the distribution of Jupyter cell reproducibility, depending on the execution count of the experiment. And of course, DL people call it experiments. So it's not just a chemistry experiment, there's a lot of similarities. So what we did, and unfortunately it's hidden, but we produced a paper that the link to which, or the citation to which, is written down the bottom, looking at the reproducibility of some of these experiments that someone who knew nothing about it said, oh, you can do this, we can do this in 5 different countries, no worries. It's been done well in East Africa. So whatever. So how do you tackle this? So what we did, we wrote a paper looking at a couple of stages and developing some mitigation strategies that might help others about this. Because we're short of time, I won't go too much into it, but we've got a few other things on Guess What, Zenodo that might explain a little more at a PowerPoint level. And so we took a desktop study first. So you go and sit there and you look at it. And we took 3 different guidance mechanisms. Some of you will know Hartley and Olsen, who've done the FAIR principles, check the reproducibility of your code, and the paper that it reports the code. Remember, it's the paper that reports the code. Look at that. I can't, Renard et al. In 2020, and I forget the other one. It wasn't Sewell, I'm sorry. We put all those together and we've created a checklist that we tested 3 target papers against, all of which used deep learning. So we took these 3 papers and we checked the description of the data set that they ran the code on, because that is quite important. We'll come back later, as you probably know. The FAIR principles, how does it stack up against FAIR principles for software and code? The description of the DL architecture, because that was something that I, as an entrepreneur, and probably the guy who thought it was a great idea, didn't fully understand, was how important the architecture and hyperparameter optimization, of course, the infrastructure and the reported experimental results and theoretical claim, which sounds a bit weird, and the shared code. So Paula had given us 10 slides, so I jammed it on. There's the right-hand side of the board. Just plotting out 3 reports for these 6 parameters. The FAIR sub-principles were the worst. They were the worst met. Now, okay, we had six little criteria that we measured it against, and that's more fully expanded in the paper. But yes, you know, they were barely making FAIR sub-principles. How it's an aspiration, sure. How measurable are they? Does it really matter? Well, if you're reproducing, possibly it does. The left hand of those 2 is about the DL architecture. You know, when we say yes, it's not bad, but it's only half of it is described well enough, so we know, okay, it was in this structure, and hyperparameterization and specifics of the shared code on the right, which I thought was very interesting. So it's that metadata that we, you know, the detail of the metadata, when you're actually trying to reproduce it, it has to be better. And of course, again, we can't read the top, it's the same heading, so it doesn't help us much. We don't communicate. Again, here we have the FAIR sub-principles now on the left, just even bigger, same thing. But we took those 3 papers. I mentioned that we tested these principles. Then I tested, you won't see this in the paper. I then took how well each paper stacked up. And I've not named them out of discretion. And you'd have to add up the columns in the table as well first yourself to check which one's which. But the latest one, the 2021 of the 3 papers, 2022 was the last paper, was actually the worst. So it's interesting, you know, and okay, there aren't many DL papers that are picking out some socioeconomic indicator using remote images, you know, Street View or satellite. So there aren't many to choose from. We're not looking at a vast resource like some of you possibly can. And certainly there are some vast resources, but it was really quite salutary. So I then went to talk to a couple of people and who do this stuff, Forum and IFA in the deep oceans, or Total and people like that. And he's actually found that matching data with the code is actually critical, and our people found that too. Actually getting the test data, again, to an entrepreneur like me, that seemed, oh, why do you need the data? You actually do, to test it first before you run it on your actual data. We've managed to do that and test it. And of course, the coder has to have a little family that they trust that will have a look at their code, which is interesting in itself. There was an interesting one here. There's a little anecdote there about a PhD student who had the code on GitHub, but multiple emails to find someone who has a copy of the actual database here. And of course, we found that with the papers we were looking at for our test cases. Libraries, the software library it relies on are out of date, unavailable, no longer supported. That is really a big issue with reproducibility, particularly with technological creep of all sorts of things, all for the better. But you know, it's a bit difficult. So you download the code and can't run it. And of course, we've already touched, and I'm many researchers just don't know, oh, we'll whack it on GitHub. Look, I have a classic example of a data paper, sure, but it was in Global Climate Change, which is a pretty high journal. The code was deposited. The reviewer hadn't looked at it. It was absolute garbage. You couldn't even read the column headings, row headings, or even the little codes for the sites at which some of this biomass had been measured in order to do carbon stuff. So that's the understanding of many of the top flight researchers and reviewers let alone code stuff. So I'm not surprised we've got a bit of a random hit here at some of the repositories where you could put. Ask your mates is really comes back to where it is. Okay, thank you very much. And I might pass this on.
Thank you, Alyssa.
You can be seen now. So if you want to smile and turn on your camera, you can.
Okay. Yeah, can we please go to the next slide? I'm going to paste a link in the chat as well. So for everyone in the room and those online, we have a little activity for you. It's a Menti. We have just 5 questions, and you're also welcome to add your questions into the collaborative notes to the Menti. So I'll give you a few minutes to start. And
is it connecting for you? It's not for me.
Well,
Sorry. Okay. It's still.
let me share my screen.
Oh, sorry. You should be able to. Sorry. Thank you. That's because you're trying to connect.
Okay. I see 1 people liking it. Okay, so it means we are in, I think. Good, good, good. Thanks. Yeah, let's go to the first question. We would like to know who's in the room. Excellent. And I know some titles are not very descriptive, so I've added a few options for you to describe your title. Excellent. Oh, this is rich for us. We really want to know who's in the room and who are we targeting. Great. We will share the results, and these are anonymous. It's just for us to understand who's coming to the session. Great. Let's go to the next question now. So because this both had one of the aims to share some mechanisms to make this new out of the talks. And
New things and new things.
so Paula, this one seems broken because there was no place to answer.
Yeah, only got a picture.
It's just a picture,
In there
yeah.
to submit button.
No, yes or no.
I did click submit.
Yeah, I didn't work.
I think this is the results page, isn't it?
Yeah, but
Yeah.
it's this
I
one's
can't-
broken, so I think we should just go on past this one,
Okay.
Paula, because you're to work.
yeah, I'll assume if you raise your hands, I can see a few of you. Have you learned
We can
something?
count.
Okay, good.
Let's
Let's go to
remember
the
the-
next one. Does your discipline have specific software registry or repository? And we will start showing some answers.
Ah, there we are.
Lots of notes.
Guess who that is? Ah,
Yeah, if you say no, can you add your discipline? Maybe we need to nudge some people or give you a list for your discipline because there's a list. Oh, cool. BioTools has been mentioned twice, Research Software Directory, Watch Meteorology. Oh, good. And going back to Alice's talk, remember there is some national registries, some institutional registries, domain specific, and also generalist repositories. Okay, there's one question there.
wait, can I cite the results?
We'll share the results later. Okay, next question. So we've mentioned a few mechanisms, but it will be excellent. If the room also let us know what other mechanisms are worth knowing. So from your perspective, what other people also should know about how to make code more visible? I'll give you a few minutes. Thanks everyone for interacting. This is great, 5 answers. Let's start showing them. More citation. Funder mandate. Are there any funders in the room or in the Zoom chat?
They always hide.
It's a call. Okay. Software heritage, online documentation, indexed by aggregators, how to build metadata into data and code uploads, all contributors. Oh, that's great. Schoolix, ambassadors and examples. Yeah, cool. So that means we have a lot more to talk about, and maybe this book is just the starting point. Link GitHub to Zenodo. Activity reports, incentives. Yes, incentives is the next question. So start thinking about what incentives do we need. Versions, metadata, licenses, policies, journals. Oh, thank you so much. Any more answers? This is the most important question, I think. So I'll let you finish your sentence if you can. 31 answers. Good, thank you. Let's go to the next one. Can you mention incentive examples that you are aware of or that you wish they exist? For example, prices for research software, conferences where people can present research software, special meetings or gatherings like Alice mentioned, or maybe code of the day, journals where people can share software and make it more visible. Any other examples are welcome as well. Does this work? Yeah. So. Good, we have JOS, Journal Open Source Software, identifiers, FOSDEM, hackathon, journal policies. I was really glad to hear that example that Alice mentioned. Hope you can hear me. That in 15 years, they have encouraged a lot of journals to actually require software availability statements. Recognition in different pathways, career paths and awards. My own research group. This is excellent. I think starting from your own research group, you're in a very privileged position. Having a GitHub repo, publish your code. Yeah, a lot of people think that it should be mandatory in publications, and publishers tell us we don't have enough people to actually look up that code and understand it and be able to review it. So we also need reviewers if we are going to make it a mandate. Better Scientific Software Fellowship in the US, Kaggle competitions, prizes for good documentation, data journals, also I'm skipping one, but there is one in Australia. The Eureka Prize is a national prize and for excellence in research software. Credit, job stability. Yes, we want contracts that last more than 1 year. That let us maintain our code. Push software metrics in institutions. Excellent. Thank you very much. And I think we have one more question. And most of you might be aware of the triangle strategy for cultural change. And it has 5 parts. And I like to have a sense in the room of what do we need more of? Do we need more policy? Do we need more incentives, more communities, more user interfaces that allow for software visibility, or more infrastructure? So that could be action points for people in the room, for people who want to make more code visibility. Good, good, good. Incentives are the highest. And excellent. With the previous question, we have a lot of examples of how we can incentivize this.
Yeah.
Okay, I'd like to give you all the opportunity to vote on this, and then we will open the floor for your questions. Thank you very much for giving us your thoughts, your knowledge and other mechanisms, your ideas about incentives. And thank you very much for your attention. So I'll stop sharing. We will go back to the collaborative notes. I'll have a look if there's any questions there, but also please raise your hand if you're in the room or in the Zoom.
Great. Paula, what are you asking for questions on? Is this a general discussion or?
General discussion.
Yes.
Yes. And you'll feel it, Paula, I think that would be.
Yeah, you can ask questions to any of the speakers, ask general questions that anyone can answer in the room. We know that there is a lot of knowledge in the room, so feel free to answer the questions as well.
We have 20 minutes.
It's good.
Yeah, which is excellent. We have one question in the room and we have one question online, Tom. Maybe we take the one from the room first. I think you can be heard, but please.
Okay, thank you.
You are first.
Sorry?
Could you say who you are first?
My name is Martina. I'm from the Netherlands. I'm from a Digital Competence Center, research data support in Utrecht University.
Can you hear that, online people? Could you hear that question, online people?
Yes, I can hear.
Oh, good, that's fine. Otherwise, I'll get you.
Yeah, it's great that you can hear it, Paula, because this is a question for you. You said writing code is research. You also you also mentioned code review, or actually reviewers for software, research software. I'm interested in that. What is in place right now to review the science that is in research software?
Okay. I said that research software is research because I have spent 5 years of my life writing research software, and that was my master's, my PhD, my work. So I was a researcher developing methods. And then about the reviewers question, I think we need more of that. So there is advanced skills that you need in order to understand software, but in research software, you also need the context of the domain that you are developing software for. So there's not that many people that know all about software, or they know about the processes that this software needs to accomplish. So we need, I think, more training, and we need these reviewers to be really recognized for the effort that they are making. In the incentives question, I think we had JOS as one of the software journals where people can actually add their software, and they will get reviewers that will help them improve the research software. There are others like that in statistics, for example. There's also open source software. So there's a few journals that are coming, but we need more of them. We need people in the bigger journals as well that are able to make these reviewers, and we need them to actually not sure if pay is the right word, but recognize the work of those reviewers, because they have spent a lot of time getting to a point where they can actually review. Hope that answers your question. Anyone else can add. I know the editors are in the room.
Just to add to that.
Okay, we've got Dan and Alice would like to add a response.
Okay, so I was just going to say, for the Journal of Open Source Software, we publish about 400 papers a year. We have something like, I don't know, 1,500 to 2,000 reviewers that are in our database. And so I feel like there actually is a fairly large community of people that are interested in doing this. It's all who have volunteered and all who want to sign up for the database because they want to become active in this community. So I think that's one answer, is that is starting to happen.
Do you think it should be a requirement in order to use software in your research project, that it should be peer reviewed and published in one of these software journals? No,
I don't.
No.
But that's a longer discussion.
Okay.
Alice, did you want to add something?
Yes, reuse of the software is in a way a peer review of that software. So if you have written software and I've used it successfully for my research, and our research is in the same domain, another person is likely to have more confidence in your software because other people are using it, which is one of the great arguments for releasing your software, because other people are going to be vetting it just through using it and finding those errors, as Paula pointed out in her presentation. Find them early. It's less expensive to change, and by expense, I mean in time and effort. So that is another way of peer reviewing that isn't a traditional way, but that does have some strength. So if I need an MCMC method, I'm going to use one that everybody else is using because I have confidence that it is a good software package.
I'll point out a little bit from my talk that the checklist that was using the 3 desktop evaluators of the code was also a very good way for reviewers, and it was targeted for writers to check that they had made their code right, and for the reviewers, so they don't actually have to run the code, but they're fairly confident that it may be good. Anyway, that's on behalf of Jeanette Machikawa, who I notice is in the online audience. We move on to Tom. Tom Honeyman, you have a question. You have your hand up.
Yeah. I've got a question. I think it's sort of the opposite question for 2 different people giving talks. Alice, you one of the things about ACSL, I think, is, or actually, if you look at the policy with publishers, is encouragement to cite both the paper about the code and the code itself is a fairly common feature. And I think one of the things that, correct me if I'm wrong, but one of the things that ACSL does is provide a mapping between 2 different manifestations of the software, if you like, or 2 different ways in which software is mentioned across literature. And this then connects with Leslie's point, where she was saying amongst those counts, it can be hard to see precisely which manifestation of the software is being referred to. So I think she was talking about how it code on GitHub might also be in Zenodo. So my question is just double checking that is a feature in astronomy and in ASCL with Alice, and then Leslie, whether you see this kind of diffusion of references to software because it has different ways of being referred to as a problem for tracking trust markers, or whether this is a mechanical problem we can solve.
Okay, so this is Alice. I will say that astronomy is currently having to grapple with many different ways of citing the same object. So ASCL typically lists preferred citation information where we find it. We feel that you as an author should be able to say, this is how I want my software cited. If your software is 20 years old, you're probably using a paper for it, and that's okay because it's a trackable method. It's not, maybe you want to add citation to the software object itself, regardless of how, and that can be in many different ways, many different forms as well. But what we're trying to impress upon authors is specify how you want your software cited, because of the proliferation of citations. And most authors want one or two things collecting citations, because the currency in academia is to have a lot of citations for one thing. So, you know, that's hard to get around. As far as, so most of the time ASCL has one record for the software, and we specify in how to use an ASCL entry for citation. We tell you, put the version number that you used in there. Not all versions get pushed to Zenodo. Not all people push their GitHub repos to Zenodo. There are ways to cite using Zenodo, and that's perfectly acceptable. We will list that, you know, we'll list whatever you want as your preferred citation, even if it's a crappy method, pardon me, but then I'll come talk to you about your method and suggest that you change it.
Now we've got, so I might move on because we've got 3 people in the room and 1 online. Maybe we'll take, Janeth, we might take one of the people in the room. I don't know which of the 2 fellows at the back put you, oh, him with the mask. Would you please ask your question? Thank you. And then we'll go over to Janeth and we'll go back to you and back to you.
Not so much a question. So Steffen Neumann, bioinformatics researcher, and I like the registries that were mentioned in one of the presentations, and one of the questions also had the infrastructure thing. And I think the 2 could come together a bit more to give the actual researcher developers more carrots to actually providing things. So what I was missing in registries is that you might have a piece of software, but then there is related artifacts out there that could be Conda installation recipes. Now you might say that the Conda recipe might be developed and managed inside the software, but then there is stuff like BioConda, which are collecting huge amounts of these recipes that help you to package and install software. And then that goes hand in hand with the biocontainers people, because if you have 1,000 recipes for installing that stuff, you can easily write one infrastructure that gives you 1,000 software containers, having all of that ready-made inside of that. So a lot of stuff that can be built by the community around that, having the registries and this more centralized infrastructures. That was my comment.
Okay, interesting. No comment from the speaker at the moment. I might pass on to Janeth.
Did we have more? I thought we had.
No, we've got, no, just a minute. Sorry, Dan, we're going to have someone online, then the fellow at the back, and this one here. And then Jonathan Pettis, who's got another question, came up later. It's okay, no one's forgotten yet. Janeth popped up her question here, which you can see on the board because it's on the chat. If I can actually move it down now. No, of course I can't. Yes, I can. Okay, Janeth, do you want to speak or can I read it out?
Okay. Hello, everyone. Yes, I was wondering, as also Paula has mentioned, that some institutions need to be reviewed if the codes are really doing what they are expected to do. If there is some other software site or wherever tool that also review as the same manner that editors review the papers or reviewers, and also if there is some manners to review the code from any paper or something, if you have any.
I think that's exactly a question that Daniel was mentioning, I think, earlier with your
viewers. So the software specific journals, Journal of Open Source Software, Journal of Open Research Software, both do that.
Yeah, okay. So they are. You don't need your mates for your trust necessarily. Okay, but will they do it without a submitted, or can you do it as a test?
You submitted it and then it gets reviewed and it gets published. And
I don't think that's quite what Janeth's talking about. I think she's talking about having a little, what do you call it, a work hub where you can get some code tested on. Does anyone offer a service like that? Isn't your code is,
Don't see what the difference is.
you're not going to publish it necessarily until you've cleaned it up, then you might publish it.
That's what the journal does is you submit it, it gets cleaned up in that process. And at the end of the process, once it's
Might be
finished,
3 iterations. I mean,
fine.
you don't mind.
that's fine. That's how.
No, sorry, we've got the guy behind, the fellow on the back row. Thank you very much. Sorry.
Neil Chu-Hong from the Software Sustainability Institute and University of Edinburgh. And actually, my comment and question follows on from that, because I think what we see in the sort of the wider scholarly communication world is that we're increasingly using preprints to test and get early feedback on research.
Yeah.
And I think one of the things that we're missing, so for preprints, one of the great things you can do is you can set up journal clubs with PhD students to review preprints rather than papers. So pre-review is one example of this, and it allows for two-way communication and building of skills of students and early career researchers in understanding both how to read, review, and write papers. The question I have broadly that I think is coming up here is, how would we set up something similar for code? So I take Dan's point that basically if you're submitting into a journal like JOS, there is a process that allows you to get that review, but it is very much towards it being published at the end. So the question is, what's the equivalent if you are doing a code version of a preprint? You're wanting to get some input from others.
That's, I think, the
And I
question.
think here as well, another of the people commented, yeah, is there enough of a pool here? And I think there's something that we can be doing to encourage this sort of journal club style peer reviewing.
Yeah.
But how would we make that scale?
I know I had my mates when I was doing my PhD and I lost them and that was it. But you know, you could go around and say, what do you think of this? Does it work? Yeah. You.
Yeah, I just wanted to raise the topic of the hidden codes. So I work in the research support, and we've been kind of interviewing a lot of researchers on how they process their code and data, and we've been around the departments at KTH, which is a technical university, so there is a lot of software code out there. And then we found out that there's so many local hit repos. Like you buy a laptop, or it's an institutional server that stands there that's private or institutional, or somewhere in between two universities you share a Git repo, but it's private. So it's not public, it's not public code on GitHub. So the first step is actually just to make people transform their mindset into sharing their code and making it visible. So I would be interested in hearing some success stories on how to hook people into the good practice of making your code more visible and the like what you get for it, basically. Because people are a bit afraid to
Oh, yes.
start.
But yeah, and there's a big cultural difference too, as it happens. We know.
Some are always pushing everything to.
And have no shame.
Some are like super scared of doing it because they don't feel that they are coders. They just write some scripts.
I was just going to say that I feel like that's part of what Paula was talking about at the beginning. And so I think she's, I don't know, maybe she has an answer for that or a comment on that.
Paula from the skies?
Yeah.
If we move on to the next question by Jonathan Peters, and we've got two more and one more in here. And yes, so Jonathan has been sitting there. Jonathan, are you still there? Hold that thought, by the way, in case she comes back. Jonathan, are you there? How can those of us at academic institutions best elevate visibility of code at the present? Prizes.
Well, but also there are forms that researchers have to fill out every year. Don't faculty members have to fill out their activity reports every year? Make sure software is on that form.
Yeah.
That's one. I mean, it might be hard to get it on there, but once it's on there, get some credit for that activity, because if it's not on that form, it's not going to get counted or seen. That's not my idea. That came from somebody else.
Well, I think, so I'll just quick say that this, a lot of the things I think suggested in the notes are things that are long things to make happen. Institutional policy changes take years to happen. Encouraging incentives within faculty evaluations or promotion and tenure doesn't just happen because I jump up and say it should happen. So, yeah. But they're good ideas. They're just things that don't happen tomorrow.
Yeah, I was more into like practical, like workshop sessions, things that could be changing the culture locally.
Okay. We're going to have to wind this up a little because I note a message from Paula saying we have 9 minutes, or from Kathy, I don't know, saying we have 9 minutes to finish the session. We now have about 5, so nothing like missing it for 4 minutes. And we really need to think of some 3 takeaways, perhaps, from the session that we might be able to follow. And I would encourage, please, those people who've got questions or ideas, and we've got more questions here, that that we should note and keep in reserve, and maybe get a discussion group going about this, which RDA is more than able to facilitate. I'm sure it's part of the deal. Yes, so we won't lose any of your questions, and I'm terribly sorry if we haven't got them today. So 3 takeaway points. Paula, is she back here again in the skies? Oh, there she is. Paula, she's going to, you have a chance to think and to start leading the 3 takeaway points, or else we'll have 25 takeaway points, which I think we do. Well, quite a few.
Oh, if we have 25, I'll be very, very happy, and then we can distill. But at least let us know what your thoughts are.
Well, we still haven't answered the question. So some of them had some good points, and then I think so that's a difficulty. So yeah.
Well, incentives are huge.
Incentives?
Yeah, and I think for me, one of the most important things seems to take away the reluctance to share this code. So there's this will come with a lot of different things. So there's cultural change, there's incentives, there's good examples, all these different things. But I think the reluctance to share, to me, is a huge barrier to the bulk of researchers. Those who have software as an output product are probably already past the point where they're embarrassed to share it, right? But I think getting rid of this reluctance is important for a lot of.
Hi, well, I think one takeaway for me is that best practices are already out there. There are examples of people sharing and citing and reproducing software like in the best possible ways. Like there's all these papers that you guys have presented showing, details of how you should be citing software. I think, yeah, the information is out there. The best practices are out there. It's more the cultural change, as you've been saying, and getting people to actually adopt those practices.
I was just going to say one example of this is the new guidelines for new faculty members that are setting up new labs. Lorena Barba has I think a very nice one about how to get students to write code, share it, write reproducible papers. I think maybe more things like that start the graduate students onto a trend where they learn good practices and don't have that cultural barrier.
Could I just mention something? It sounds very first world country. I mentioned that I even go back to people who maybe have published the code but really haven't had it tested by anyone, and the reviewers maybe have put in a journal, didn't require it. But so think about other programmers in other parts of the world, and we may have cultural reticence to have it shared, maybe don't have the infrastructures and the institutions that are responsive. Is anyone done any cross-cultural comparison? Yes.
Well, actually, so we run some carpentries workshops during college, and then we're in the same time zone as Africa.
Yeah.
So we had some co-sessions with some people in Zimbabwe and South Africa, and also here. And they were sharing everything on GitHub because it's for free. So they had no problem. I mean, they didn't have any local infrastructure, so they were already sharing everything because that was a free service for them. So It was the opposite, actually.
It's not monetized perhaps also? Yeah. What about the rewards? Anyway,
Yeah, but the rewards is another thing, but
yeah, okay.
there was no reluctance to
Yeah, that's right.
get your
Mm.
code up there.
Right, yes, oh gosh. We got two more there, yes. Please.
I was just going to mention there's an ongoing study called the Harbingers Survey, which is looking at early career researchers across the world. It's not specifically around software and code visibility, but there are some interesting things there around different cultural attitudes to sharing and open science that you brought out for that. So that's really interesting because it is a global study and it has tracked, I think, since 2015. It's got a bit derailed by the pandemic. It's only switched to a different type of study then, but really interesting to see, as you said, the differences that different cultures present towards sharing.
Yeah, and I do think that's an opportunity like RDA. So, but yes.
Yes, I was
almost last.
just going to point out that it's also important that part of the cultural change, part of the reluctance people are having is because they're afraid of being ridiculed, right?
Yes.
So also having conversations about, oh, you're not sharing in the right repository is a poor way to go about it. It's like you're trying, acknowledge the attempt and go, okay, I see you're doing this because it's a free, it's what's available for you. That is awesome. Did you know that there are other services? It might be working better for you. Like, don't go about attacking people for trying because that's going to stop others from trying as well.
We've got a few nods from the speakers.
Yeah, so many times it's been suggested by somebody on the ASCL advisory committee that we do a star system or some kind of ranking system for the software. And I'm like, absolutely not. I want people to release their software and I'm going to lavish praise on them, no matter how crappy their how bad their software, sorry, how bad their software is, or whether it's undocumented or whatever. I want the code in whatever form it is if you used it for research. So, so no judgment. Kelly Cruz, who works in astronomy, also doesn't like the language, people dissing other people for the language that they use. And when she runs a workshop, you do not do that because she will. Yeah, she's ferocious. So and you know, good that she is. So no blame, no shame.
Well, I can't add Paula because you're sharing your screen, so I can't chat for some reason. Anyway. I know you've got the name for Harbingers. Thank you very much for that.
I've added a lot of the notes. Thank you very much, everyone. Yes. If you left your email, I promise to send the results of the Menti, and the collaborative notes are available.
Yes,
thank you, Paula.
That was fantastic. Thank you very much, Paula, for facilitating this. And you're going to put the Mentimeter up on the notes, aren't you?
Yes.
I see what's. Oh, yeah, honestly, that's what happens.
Otherwise, I wouldn't.
I thought we'll start with my thing, but basically the first time he published code 9. I can see you want to link on the app. He's got a very good human about him, so very good at posts. That's release your data.